Welcome to LabMinutes.com. In this video, we will look at an EasyVPN with a pre-share key and certificate authentication using a Cisco ASA firewall as a headend device. As I mentioned in the previous video with the router as a headend device, the configuration on the headend side is pretty much identical whether you have a software client or hardware client, except the hardware client is capable of two additional modes called Network Extension and Network Extension Plus, which allows the true IP subnet behind the client to be seen by the subnet behind the headend. So there's no NAT required or the IP to be assigned to the client, and the traffic will not be NATed to the IP allocated by the headend. So it's the bidirectional access in the sense, which we'll look at in a separate video. In this lab setup, we're just going to keep things simple. So on the headend side, we have an a Cisco ASA firewall, and on each side we have a VLAN. On the left-hand side, VLAN 32, and the right-hand side, VLAN 128, and we are going to provide connectivity between those two VLANs. Okay, so let's start our config on the firewall device. Show you the interfaces that we have. We have the inside interface 96.252 and the outside, which is 111.11. So if you look at this physical topology, you can see it right here. Okay, so the first thing we would do is to create a username for the client XAuth. We're going to call username site with the password Cisco. Next, we're going to create an IP local pool since we're going to be doing EasyVPN client mode, which is the default. So we need to come up with a IP pool that will get allocated to the client. We'll start with 100.32 to 172.16.100.63 with a mask of /24. Next, we're going to create a split tunnel access list. All the remote site needs to access is the VLAN 32, so split tunnel access list will have permit IP of 172.16.32.0 as a source. Any. Next, we're going to create group policies, which is where all the attributes that will get pushed to the client define. Again, same idea as the headend router scenario. So we're going to call it EasyVPN group. And since we're going to be storing the attributes locally, it's going to be internal. Then it's going to be group policy EasyVPN group attributes. We're going to start defining attributes. You can see there's a lot of attributes that you can define here. So just to make our life easier, I'm going to copy that out, put it in the notepad, and we can go through that. There we go. Okay, first we can do address pool, value, and we call that EasyVPN pool. Yeah, we don't have backup server, no banner, since nobody's gonna see that. This is on the hardware client. Do default domain. Again, value LabMinutes.com. You can do DNS server. That would be 172.16.32.40. Okay, next we will do password storage. So we are going to allow the client to locally store the password. So every time authentication is required, there's no need for the credential to be re-entered. So enable. We're going to enable PFS. Let's see what else we need to do, or we can do. Split tunnel policies. Split tunnel policies. We're going to do tunnel specify. And then we have a split tunnel network list, and that would be our split tunnel ACL that we created. So show access list. Okay. XAuth. We are going to enable that. So to do a re-authentication when there's a rekey or the key has expired. Okay, we're going to do idle timeout. Let's see, there you go. And let's do 1 hour. And we're going to define VPN tunnel protocol. And here we're just going to use IKEV1, nothing else. Okay, next we move on to the tunnel group configuration. We're going to call it EasyVPN also. Group type. Here it is considered remote access. Once you have defined the type, then you can define a attribute. So start off general attributes. We'll make sure the authentication server group is local, while you can always do radius if you have that set up. So local. And then we get default group policy, and we call that EZVPN group also. Okay. That's all you need for the general attribute. Next we'll do IPsec attribute with the IKEV1. And also just keep in mind this particular ASA is running 8.4 version of the ASA or software. So if you run anything earlier than this, you might not see IKEV1 or IKEV2 options. So the syntax for you guys will be a little different. It's just starting 8.4, there's a support for IKEV2, that's why we now have to specifically choose whether it's version 1 or version 2. Okay, so pre-share key is going to be Cisco. Going to do ISACamp keep alive, threshold 10 seconds, and a retry of 3. Okay. So now that we have that defined, we're going to move on to the crypto configuration. And again, now you see the option of IKEV1 and IKEV2. So V1, policy 10, authentication pre-share, encryption, you can do AES 256, hash SHA group 2, and a lifetime of 84,600. Okay, now we're going to enable ISACamp. Actually, before you do that, your identity. So you define identity, and here we're just going to do address. So firewall will use the address as its identity. And then we're going to enable IKEv1 on the outside interface. Okay, next we're going to move on to the phase 2 configuration, which is the IPsec transform set. We'll call ESP AES256 SHA, and that would be ESP AES256, and then ESP SHA HMAC. Okay. And then we're going to clear the F bit on the outside interface. Now we get into the dynamic map configuration, which we'll call EasyVPN map. Let's choose the sequence number 1000. And you can either set or match. Since it's a dynamic map, we will not be matching anything, but instead we'll set. Start off with IKv1 transform set, which is the one we just defined. So let me scroll back up a little bit. Here we go. And then we do PFS. You have security, association, lifetime. We have a choice of second and kilobytes. So second, we're going to do 8 hours. And kilobytes, we'll do 1 gig. Okay, now the last thing that we're going to set is reverse route. Okay. Now we create a crypto map, give it sequence 10. We're going to use the IPsec ISACAP negotiation and define and tie that to our dynamic map earlier. And then we enable the crypto map on the interface. Okay, so that should be all the configuration we need right now on the ASA. Just check real quick, tunnel group is there. Group policies are also there. Okay. And all the crypto configuration as well. So these are the crypto maps. And the phase 1. Okay. So now let's switch our configuration to R2. Configuration R2 is pretty much the same whether the headend is the ASA or a router. So here we specify the ISACAP policies, encryption AES256, authentication pre-share key, group 2, hash, and lifetime by default is 86400. Okay, we're going to do crypto ISACAP keep alive 10.3, crypto ISACAP XAuth timeout 5. Okay, next we're going to get into the IPsec client EasyVPN config. We're going to give it the name EasyVPN. Now from top down, ACL is when you have a multiple subnet you need to be included in the tunnel, so we're not doing that. We do not have backup headends. Connect, we're going to use auto, so it always stays connected. We're not doing encapsulation with the TCP. Now we need to give it a group name, and we call it EasyVPN group. with the key of Cisco. Make sure there's no trailing space. Idle time, stay at 1 hour. Mode, let's see. We're going to do client, just to keep things simple. We're not doing any NAT, so peer, this is the IP of the headend, which is 111.11. We'll make it a default. And we have username and XAuth. So username, we created a site with password Cisco. And XAuth, user ID mode, and we're going to use the locally store credential. So it doesn't require user intervention as far as the XAuth authentication. Okay, now next we're going to enable EasyVPN on the outside interface. So tell it's a group EasyVPN being an outside interface, and then do the same, but this one will be the inside interface on F00. Okay, so you can see ISACAM is on. And we now have a QM idle for phase 1 with a bunch of log messages that indicates the VPN is up. So let's look at phase 2, which is Crypto IPsec SA. And we can see that it's active. Currently, so far, there's no packets encrypted or decrypted. So on the test PC, we have in the VLAN 128, we're going to try to ping 32.1. Okay, and we can ping successfully. If you do on the client side, show crypto IPsec client EZVPN. Here the IP has been allocated to the client is 100.32 with the split tunnel subnet of 1632.0/24. Okay, and to prove that right now when we ping 32.1, that's the switch IP. So if you do a debug IP ICMP on the switch, you can see the switch is being pinged or is sending an echo ICMP echo reply to 100.32, which is the IP that was allocated to the hardware client. Okay, so our tunnel is up and active. Now let's take a quick look on the firewall side. There's similar commands with the show crypto ISACAM SA. You see AM active. With the IP and the user, you can actually do detail to see type of encryption, hash. We look at phase 2 and see encrypt decrypt without ping that's running right now in the background. You can also do show VPN session and remote access IKv1 IPsec. And here's a little more detail or information about the client with the assigned IP, encryption, hashing, the groups that's currently used, when the client logged in, how long it's been up for, and inactivity timer. So this is a very useful command. And also, of course, username. Okay, so now that we have the tunnel up and running on the pre-share key authentication, next we are going to try to change our authentication to certificate and see how that works. Okay, so we're going to start with modifying our config on the ASA. Since we're going to use a certificate to authenticate, we no longer need username, so we're going to go ahead and get rid of username. And just to show you, we already have a certificate installed in the firewall. If you're not familiar with how to install the certificate on the Cisco device where there's a firewall on a Cisco router, we have a separate video that kind of walks you through of the process. So I recommend you to check that video out. But here we already have the certificate installed, so show crypto CA trust point. So we have a trust point created. Let's do show run crypto CA trust point. Okay, so a trust point is called LabMinutes CA with the NetSEF SCEP protocol that points to this particular URL for the enrollment. And for the certificate itself, so show crypto CA cert. We have a firewall cert, and then we have a self-signed root CA cert. Okay, now to support the certificate authentication, we can create a new crypto IKv1 policy. Since we want it to prefer this policy, we're going to make it a lower sequence number or higher priority 5 with authentication type. Instead of pre-sure, it's going to be RSA SIG. Encryption, going to say AES256 hash group 2 lifetime 86400. Okay, and under the tunnel group, so our current configuration tunnel group looks like this. To change from pre-share key to certificate, we're going to get rid of the pre-share key command, and then we're going to attach or tie the tunnel group to a trust point. So the ASA know which particular trust point, hence certificate, the ASA itself should use for certificate authentication. And we'll just show you, we call our trust point LabMinutes CA. Okay. And we also want to make sure we disable XAuth. I mean, you can do XAuth on top of the certificate, since it's a totally two separate process. But here, to make things a little simpler, we're going to disable XAuth totally. And it's actually, the command is none. So disable user authentication. Okay. That should be it for the firewall for now. Let's switch to R2. R2 currently show cry PKI cert. So R2 has a certificate installed already. But it has an incorrect OU. So the OU needs to equal the group name. On the headend side, which is EZVPN group, so we have another certificate that we can use right here. Look at the detail. This guy has a OU equal EasyVPN group. So we're going to create another trust point and import that. So crypto PKI trust point, I'm going to call it EasyVPN CA. We can just pretty much copy what we have on the other one. So let's see what we have. Show run. Let's call PKI. There's our notepad. Okay, let me copy this part out. And OU is supposed to equal EasyVPN group. Everything else we can leave intact. Okay, so we're going to do enrollment terminal. But first we have to authenticate the trust point, which is installing the self-signed boot CA that we have, which is this one right here. Basically copy the whole thing and paste it. Type quit, and looks like our time is off. I seem to always have that problem since we do not have NTP on the internet for the router to sync with in the lab, so we're just going to set that up manually right now. That would be set. There you go. Let's try that one more time with crypto PKI authn EasyVPN CA. Quit. There you go. Now it's asking you to verify the fingerprint. Let's go ahead and accept that. Now it's imported. Next we're going to import PKI import the certificate that we have. Cert. Copy and paste from the certificate that we have ready. Quit. Now it says successfully imported. Let's verify show crypto PKI CA cert rather. And now you can see we have a router 2 certificate with OU equal EasyVPN group that is associated to a trust point EasyVPN CA. Okay, so we should be good. Next we just need to modify our crypto ISACAM policy from pre-share key to RSA-SIG for signature. And we can go ahead and under the IPsec client, EasyVPN, we can remove. Let's do this. There you go. So let's see what we can remove here. So we no longer need a group name because that's will automatically be obtained from the OU on the certificate, so no, and we certainly do not use a pre-share key anymore, so that can go. We do not use on the head end we disable XAuth already, so anything that's related to XAuth, which is username, and the XAuth command, all those can be removed as well. Okay, so now we have left with okay, that's it. Pretty straightforward config. Before I reset the tunnel, let's run a debug on the head end. So crypto ISACAM 127, and here we go clear crypto SA. Okay, you can see there's an activity here on the debug. Okay, so you all just to disable. It looks like the tunnel went down but never recovered, and immediately we lost our ping to the 32.1 IP. So let's take a look at the debug and see what's going on. Okay, so everything comes through, and let's see if we can spot some of the key messages here. Looks like it went all the way to the certificate part of it. It also did the NAT discovery, so it must have passed the phase 1 almost, the crypto suite negotiation. It just kind of seems to find the message here. But it got to the part where it negotiates or discover the NAT and start exchanging certificate. As you can see here. And then right here it said NAT is not, device is not behind NAT device. And now it's trying to look up the OU, and you can see connection lands on the EZVPN group, which is what the string that we define on the OU equal. Others say no valid authentication type found on the tunnel group, certificate validation fail. So something's happening with the certificate validation. So let's run another debug on crypto CA and see if we will be able to get a little bit more information as far as why the certificate validation failed. So here, clear that. Actually, it's clear crypto IPsec client EasyVPN. So give it a little kickstart. And still failing, looks like, but at least we have more debugs to look at. And let's see. So it's looking for a trust point, and it found a trust point. And then it said check key usage with extended key usage OID. This long string of number. And then this is where it said the OID for the key extended key usage is not acceptable. So that's where the validation failed. Okay, and the reason for that, from what I've seen and read, it seems that the certificate that's been issued by the Microsoft 2008 certificate server, it seems the extended key usage OID is not, whether it's not acceptable or recognized by the Cisco ASA. Okay, so if you run across this issue, and when you run the debug crypto CA, and it come up with this particular error message where it caused the certificate to fail, then what you would need to do on the ASA is you go under crypto, so show crypto CA. Okay, you go under the trust point, and if you do question mark, you see a command that said ignore IPsec key usage. So there's a command that will tell the ASA to basically ignore the extended key usage OID check, or skip that. So you can go ahead and do ignore IPsec key usage. And here it's just to give you a little warning, because if you have that enabled, there's a chance that the certificate might be used for the purpose it's not meant to be used for. I can see as soon as you do that, immediately a ping came back, and if you jump back on R2, see a log message that tells you the tunnel is up. Okay, so our connection must have been restored. If you do show VPN RA IKE PSEC, go. Everything looks good. Connected. Show crypto CA. Show crypto ASA detail. And here authentication, we are doing RSA authentication, which is certificate authentication. Okay, and our phase 2 is up and everything. Encrypt, decrypt packets is incrementing, so we know that we have a healthy connection created. Okay, so that wraps up our video on the EasyVPN using a Cisco ASA firewall as a headend. Thank you for watching LabMinutes.com. I'll see you guys in the next video.